All right, section 4.3, we are going to talk. Now, we've used this word before, but we haven't used it concerning these triangles. This whole chapter is about triangles, right? So you've seen this word before, and it's congruent, right? We've used that a lot. We've kind of used it interchangeably with what other word? I said these sides are congruent, or you could say the sides are equal to each other, okay? Congruent and equal, right? Not congruent parallel, congruent and equal. Would you agree? And I've been pretty lax on you saying either equal, the angles are equal, or congruent. To me, it kind of means the same thing. Technically, it's a little bit of a difference between the two. Some teachers would never say these angles are equal. They would say the angles are congruent, or they might say the measures of the angles are equal. But see, it's such a thin line of going back and forth. It doesn't really bother me one way or the other. But on triangles, you definitely want to use this word right here. When we talk about triangles, you definitely want to say the word congruent. You will never say equal triangles. That will bother me, okay? So we won't say that. So congruent triangles is what we're talking about. Well, what's the little symbol for congruent? Do you remember that? It's an equal sign with a what? Little squiggly thing. I don't know if that has a name or not, but we'll call it a squiggly thing. Is that all right? All right. So anyway, that's the symbol for congruent. So let's talk about what congruent triangles are. So let's grab a triangle here. Looks like a turtle. Where? Yeah, that's a good idea. I second that motion. Where'd you hear that from? All right, here we go. Here's a triangle right here. Let's push it over to the side. Let's make it a little bit smaller. About right there. Okay. So there's a triangle right here, and let's do that. Or let's do this. Let's put, I don't know, let's put one arc right here. Actually, I'm not even going to do that yet. Let's just do this. Watch. Now, since I have this computer program, I can do this. I'm going to copy and paste, right? You've done that before, right? On a computer. So I copy. What's copy on a computer? What do you click? Do you right click? What is it? Control C, right. Do Control C. That's a lot better than, or Command C. If you have a Mac, it's Command C. You know, the little squiggly looking thingy on a Mac, yeah. Anyway, this is a PC, but we do Control C, and then what's paste? You'd think it would be P, wouldn't you? But it's V. Why do they make it V?
P is print.
Yeah, P is print, but why make it V? Oh, is that what it is? Visa val? Nah, it's because it's right next to C. That's my feeling on it. Control C, Control V. It's right next to the C, so it's easy. Control C, and then boom, Control V. So I copied and pasted. All right. I've looked at you like twice already. Okay, I think you get the idea. No, I'm looking at you. All right. Because every time I start saying something, you guys have a conversation. All right. Everybody ready? So here we go. We've got two triangles. I copied and pasted. If you don't believe me, I'll take this and I can put it right on top of it. And it's the same exact triangle, isn't it? All the angles are the same. Are you listening? All the angles are the same. All the sides are the same and that kind of thing. Well, that kind of tells me that I have, what do you think? They're congruent triangles. We don't say they're equal to each other. We say they're congruent to each other. Now, there's a lot of stuff that could be equal to each other. Watch, if I put this right on top of here, all right, like this, what do you think is true about this top angle on both of those triangles? They're equal to each other. They're congruent. Right, you can say congruent or equal as far as the angles and the sides. I don't care. All right, so let's start marking. Remember I was going to do this a little earlier? If I marked this right here, I'll tell you, let's label these triangles to make it a little easier for us. I'll call this triangle ABC, and we'll call this, I don't know, D. No, I can't call it C because that's a C. We'll call it DEF. Okay, we won't be that crazy with this. But watch, if I said, if I put one arc at angle B, now remember, I put this triangle and I stuck it right on top of it, right? So what angle over here must equal angle B on this triangle? Angle E. So I can put what? One arc with angle E. Would you agree? All right, let's keep going. What about angle A? I'll put two arcs with angle A. So what's equal to angle A over here? Angle D. All right. So angle D is equal to angle E, would you agree? Or A, sorry. Do you agree? All right, talk to me now. What about C? So I'll put three arcs on it. He meant the three arcs. So angle C would equal what? Angle F. All right, very good. Everybody see that? All right, so those have to be equal to each other. If I took this triangle and I stuck it right on top of here, angle A and D match up with each other, don't they? I'm going to throw another word at you, a word that you've seen before, but we're using it just a little bit differently. All right, and these are called corresponding parts. Now we're going to be using that phrase every once in a while. So corresponding parts. And when I say parts, what parts do we have of a triangle? We have basically two parts. What do we have? Sides and the angles, okay? I'll go angles and sides since we did the angles first, okay? So we have angles and we have sides. Did you follow me? So when I talk about the corresponding parts of a triangle, the triangle really only has two parts, doesn't it? It's got angles and it's got sides. When I say corresponding, they're the ones that match up with each other. Now, I'm not talking about the corresponding when you did the parallel sides and the transversal. Remember that? Okay, wasn't that long ago, right? We did two parallel lines cut by transversal. We're not talking about those corresponding angles. We're just talking about corresponding angles. If I took this, picked it up, sat it right on top of this, which ones would match up with each other? You with me? Okay. So A and D would be corresponding angles, wouldn't they? And they're equal. So if I have congruent triangles, A and D would equal. What about B? B would equal E, and C would equal F. You get it? Now, there's other parts. There's angles, but there's also sides. So what if I did this? What if I said that I'll put one tick mark on AC? What would equal AC over here? DF. Okay, DF would equal AC. Agreed? Again, because if I took the triangle, stuck it on top of the other one, those two sides would match up. They're what kind of sides? They are corresponding sides. Okay, they're corresponding because they're the ones that match up with each other. What about this BC? What would equal BC over here? Good. You get the idea. It's not too hard to see, is it? And what am I going to put here? Put 3 tick marks here, and what's going to equal AB? DE. Very good. Are you with me? So look, there's 6 things that I know. If I know the triangle's congruent, I know 6 things. I know all 3 angles, the corresponding angles, right? The ones that match up with each other. I know that they've got to equal each other. And then I know that the sides, the corresponding sides, equal each other. If I took the 2 triangles, stuck them together, the ones that match up, the ones that sit right on top of each other, right? They have to equal each other. Make sense? Yes. Good. I don't know. I was just thinking of this off the top of my head. What if I did this? What if I copied and pasted and I hit the shift button? Did you know that when you work with graphics? If you hit shift button and you bring this in, you see, it doesn't stretch it out or anything. It just makes the whole thing smaller. So it's, we'll talk about this later, but look at this. Are these two, this triangle looks just like this one, doesn't it? But if I took this and picked it up, would it fit right on top of here? No, if I put it here, look, the sides aren't the same, but guess what are the same? The angles. That's right, the angles are the same. So look, see if I put that there, that little angle would match up, wouldn't it? And if I put this over here, that angle would match up. Isn't that cool? All right. Don't worry about it. Just this is just free of charge, okay? So just enjoy it. Watch. Are you listening? Okay. So is this triangle congruent to this triangle? No. No. Well, all the angles are the same, right? Yes. But what I say when we talk about congruent triangles, they have to have the same shape and they have to have the same size, right? Well, this is the same shape, isn't it? It's exactly the same shape. But is the size the same? No, no, it's not. All right? All right? So the size definitely is not the same. So what congruent triangles have to have the same shape and what else? The same size, okay? The shape is determined by the angles, isn't it? And the size, S-I-Z-E, is determined by what? The sides, S-I-D-E-S, okay? All right, it sounds kind of the same when you say it, but, all right? Make sense? All right, let's label this. Now, we already learned how to label a triangle, but what we're going to do, it's very important that you understand what we're going to do right here. Look at this. You could call this triangle anything you wanted to, couldn't you? I mean, within these 3 letters. Okay, I could call it triangle ABC. What else could I call it? CAB. What else? CBA, BCA, BAC, all kinds of different things, couldn't we? All right? Let's just pick one. Let's just go ABC to make it easy. All right? Now watch, this is very important. I could have taken this triangle right here and called it any of those combinations of those 3 letters that I wanted to. But when I say that it's congruent to another triangle, if I say that it's congruent to this triangle right here, I can't just call this anything that I want to. I want the A to match up with what? The D. I want the B to match up with the what? E. And I want the C to match up with the F. So what am I going to call this triangle over here? DEF. It's supposed to be a D. All right? DEF. You with me on that? It's very important that you do that. If I tell you to label the triangles, I think you had a question on the homework. It says, all right, here it is. It says state that the polygons are congruent by identifying all the corresponding parts, then write a congruent statement. When it says write a congruent statement, it means to take this triangle, call it whatever you want to call it. We decided to call it ABC. But this one has to be named in the same exact order as this one right here. You follow me? So if I call this triangle ABC, I have to call this DEF. So when they say write a congruence statement, that's what it means. This is a congruent statement. What's another way? That's not the only possible answer. I could have called this anything I wanted to. We gave a whole bunch of possibilities earlier. CAB, all right, cab. Now watch. If I call this, watch, CAB, what am I going to have to do over here? FDE. That's very true. Okay, I have to call it FDE. Now look at it. Just looking at this stuff right here and covering up, I'll do what I did in the last class. Watch, let's say we cover all this stuff up right there. And you say it's not covered up. Sure it is. Right now it is. Okay? So it's all gone, right? Now, without looking at the triangles at all, I can look at this and I can tell you which angles are equal to each other, right? I can tell you which sides are equal to each other. So, just looking at this, angle A would equal what? Angle D. All right? Angle B would equal angle E, because that's the second one. Angle C would equal angle F. I could also write down the sides, couldn't I? I could say side AB equals what over here? Side DE, without even looking at the triangles. Okay? That's why it's important when you do your congruent statements that they are in the same order. All right? If these are in different order, then you wouldn't know which angles were equal to each other. It's very important that you do put these things in the right order. If you don't put them in the right order, I mark it wrong. You understand? They have to be in the right order. I could call this first one whatever I wanted to, but the second one had to match up with the first one. Look at this. We said that C and F go together here, right? Because they're both the third one. Well, look where C and F are here. It's the first one, but they're still both the first one, aren't they? See, C and F still go together, don't they? A and D still go together here, and they go together up here as well. Make sense? All right, so that's the kind of stuff that they're going to ask you to do. All right, let's do a quick little example, and then we'll be finished. It's been pretty easy so far, hasn't it? Okay. All right, I've given a triangle right here. Watch what I'm going to do, though. I'm going to take this triangle, I'm going to copy it, and paste it, and I'm going to, like, twist it around. You watch me? Watch, I'm just going to go like this. Now, before I twisted it around and all that kind of stuff, they were still, listen to me, they were still congruent to each other, weren't they? I copied and pasted. They were exactly the same triangles. Now, just because I twisted it around, does that mean that it's any different? No, it's the same two triangles, isn't it? So are these two still congruent to each other? Absolutely, okay? But I want to show you this. Tell me something about this third angle right here. If I have these two angles equal to each other, or if I have these two angles equal to these two angles right here, they're not equal to each other, okay? So it's not isosceles. So this one and this one are not equal to each other, but these two angles are equal to these two angles over here. Tell me something about the third angle then. Because we just learned something. What did we learn about all three angles of a triangle? They equal 180, right? So let's just, I don't know, let's just make some numbers up here. Let's say, I don't know, that looks like 70. And let's say that's 50. Okay, let's say it's 50, all right? We're just making guesses. It doesn't matter, okay? If this is 70 and this is 50, altogether, what is that? Okay, so what's this angle down here going to be? This is going to be 60. I know it's not exactly to scale, but I'm just throwing numbers here. Now listen to me. Listen. If this is 70 and this is 50, then this has to be 60. Well, look at over here. We said that this angle and this angle are equal. So what's this angle have to be? 70. We said that this angle and this angle are equal. So what's that got to be? So tell me something about that third angle. It has to be 60. Do I have to do that math all over again? No, because I know I'm taking the same two angles away from 180. Agreed? So we have a theorem that says this. We have a theorem. It's called the third angle theorem. I'll just shorthand it. It says this. If I have two angles of one triangle, listen to me. If I have two angles of one triangle equaling two angles of another triangle, what must be true about the third angles? The third angles must be equal to each other. Do you see that? Okay. All right, that's pretty much it. I'm going to give you a worksheet, and I'll let you work on that.